All right, welcome everyone to Orlando.NET User Group, otherwise known as OneTug. Today is September 2nd, 2021, and we're joined by, I hope I do not mispronounce your name, Veronika Kolesnikova, who's going to be talking about machine learning for .NET developers. Just a quick reminder, tonight's meeting is being recorded and will be shared later on YouTube once we get it posted. So your continued participation in the meeting is your consent to be recorded. A couple of just quick reminders. We do ask that when you're not asking a question that you do go on mute and to consider turning off your webcam if you have it on during the presentation. If you do have a question, go ahead and use the raise your hand feature. And when you're called upon, come off mute, ask a question, or if you prefer, go ahead and use the chat window, whichever makes you happy. Tonight's agenda, we'll do the welcome announcements. Just a reminder, we are being recorded and we are having the talk tonight by Veronika, talking to us about machine learning for .NET developers. Orlando .NET User Group board and Code Camps members are these fine folks here. Santosh is on the call, I'm on the call. I don't know if Tanner or Todd or Andy are on tonight. A couple of quick resources. You can find us online at onetug.net. Meetup page is usually our most active place, followed by Twitter. And you can also find us on YouTube and Facebook and LinkedIn as well. Upcoming meetings, we do have one coming up later on in September on the 23rd. We'll have Sweeky talking about the upgrade assistant in .NET MAUI. Can't wait for that one. There's no monthly sponsor this month, but if your company is interested in sponsoring, go ahead and give us a shoot us an email at board@onetug.net. And at this point, I'd like to open it up to the community. If there's any announcements anyone would like to make, if there's anyone looking for work, anyone hiring, any upcoming conferences or meetups that you want to plug, feel free to come off of mute and give it a go. All right, we'll take it as no. Okay, tonight Veronika will be talking to us about machine learning for .NET developers. She's a senior software engineer and a Microsoft MVP, a specialty in AI. She's passionate about backend web development, mainly with Microsoft technologies like C#, .NET, Azure. She's a public speaker and a hackathon volunteer. Veronika holds a master's degree in information technology. In her free time, she likes dancing, traveling, and practicing aerial yoga. Do you have any pictures of that? that seems intense. And you can find her online at Twitter and LinkedIn and her blog as well. And
yeah, that, I just want to say I'm actually gonna my phone's gonna die out of battery soon, so I'm just tuning in for the beginning of it. So thank you.
Sure. All right, and with that, we'll go ahead and turn it over to Veronika.
Thank you. So let me share my screen. So you can see my slides. I hope you can see them well. If you can't, if you can see anything or hear me speaking, definitely let me know. We have the chat here. I see some thumbs up, so that's good. Thank you. You can raise your hand if you have any questions. But now let's start. So today I will be talking about machine learning for .NET developers. Here you can see my name. My name is Veronika Kolesnikova, and my Twitter handle. I am trying to be active on Twitter to post about tech stuff, something interesting. I also have a blog. When I create new posts, I usually announce them either on Twitter or on LinkedIn. If you decide to find me on LinkedIn, definitely write a note how you know me. Otherwise, there are some random invites that come to my inbox, and I don't know who those people are. Okay. So Tim actually introduced me really nicely. He pretty much said everything about me, so now you know who I am. I am 3 times Microsoft MVP in AI. I currently am working as a senior software engineer in Boston, Massachusetts. I mostly used to work with Microsoft technologies like C#, .NET, Xamarin, all those cross-platform solutions. They are really exciting for me. And obviously, I love artificial intelligence and machine learning. But recently, I started working more with Java and Node.js. And here are my hobbies. You already heard about them. I do have pictures from my aerial yoga practices. Not right now, not today, but if you follow me online and ask for pictures, I can show you a couple. So now let's move forward with the actual content of this presentation, and we'll start with artificial intelligence and machine learning. Those two things are really popular right now. They became actually buzzwords. People use them everywhere. In lots of cases, they use them interchangeably. But let's figure out, are they the same? Are they completely different? How are they related to each other, and if they related to each other? And we'll start with artificial intelligence. Artificial intelligence in general is something that we as humans are good at, but machines are not. So using logic, if-then rules, and decision trees, and some other techniques, developers or data scientists, they are actually trying to mimic human logic to actually behave like a human or understand like a human. So that's the artificial intelligence definition. Actually, artificial intelligence has more than 1,000 different definitions. So that's not the only one. If you find something else online, that's totally fine, but it's just general. The more generic one that I personally like. Okay, and next here is machine learning. And machine learning is a subset of artificial intelligence. And it's basically a combination of statistics and some software or technology that we are all developing. And using those techniques, we are making machines to improve at tasks with time and experience. There are lots of different tasks that are available for machine learning, and we were getting more and more tasks available for machines because we have more and more data. And since I started talking about the data, when we have a lot of data, we are trying to use it in the most efficient way and trying to organize it by creating multi-layered neural networks. Here we have deep learning, and deep learning is a subset of machine learning that actually that subset is using those multi-layered neural networks to actually not only make those machines be better with time and improve at tasks, but at the same time perform more complex tasks like image recognition and speech recognition. So if you heard about Azure Cognitive Services, all of them are based on deep learning techniques. So now we kind of understand what's going on with artificial intelligence and machine learning, and maybe we are ready to actually start doing something. But before we jump into creating machine learning models, because that's the core of every machine learning task. You need to create a model that will perform some kind of action, maybe recognize speech or maybe perform optical character recognition. So let's talk about data. So the machine learning and especially your future model, it might be a black box for you, but generally you can see a cute picture here that you are basically feeding data into the model using specific types of algorithms that combine that data and create that machine learning model based on the data that you provided. So there is no magic there. It is basically garbage in, garbage out. If you put in appropriate data, maybe irrelevant data, or data that is just, has all the garbage that you collected, then you're not gonna get an efficient model. Microsoft actually created principles and they organize them together. Those are principles of responsible AI. If you are interested in creating your own models, then definitely check them out. They are really important and they cover all the basics. So the data, it has to be clean, it has to be up to date, and also you need to make sure that you are removing all the biases there as much as possible. Also, when you start reading about the responsible AI, you'll read about the tools that Microsoft provides for you to use and actually clean out your data to make it suitable for your machine learning models, for training those models. By here, I am showing just several of techniques that you need to keep in mind to actually organize your data. You need to filter data. You need to replace missing values. So if you have data which has a lot of missing values, then your machine learning model in the end, it won't be that efficient. It won't perform well. So you need to clean it out before you actually start training the model. And then you can use normalizers. Here I am just providing a couple of examples, but there are a lot of them available. You can use minimum maximum normalization. You can use binding. You can remove default stop words like a, is, and etc. Machine learn ML.net. I wanted to call it machine learning.net. Technically it is. So ML.net actually has some tools to help you to clean out your data. And since I mentioned ML.net, I need to actually tell you what's going on with ML.net. I'm not sure how many of you heard about ML.net or worked with ML.net. If you have any experience, definitely share in the chat. So it will be interesting for me to see how many people actually used ML.net or heard about it. But overall, ML.net allows you to train, build, and ship custom machine learning models using C# or F#. So for us .NET developers, that is perfect. I actually started using cognitive services first. So I don't have any machine learning background. I mean, now I already have some background, but when I started, I didn't have a proper education. I'm not a data scientist. I didn't have any experience. So I started with cognitive services. And then I like machine learning so much that I started thinking about actually creating my own machine learning models using the data that I have. And then I actually found ML.net. It is relatively new to general public, but it has been used inside Microsoft, meaning internally. for so many years. It's been used in so many products like Office Suite, Office 365, and some Power Platform. So there are lots and lots of applications that they already use ML.NET. So it's well tested. It is available for us, and it is open source, as you can see here on my slide. You can go to GitHub. You can check the code. You can see how it all was built, and at the same time, they have awesome examples there. So you don't have to start completely from scratch. You can get the examples. They also have amazing documentation. I keep telling people that Microsoft has really good documentation, and I'm not just saying it because I've been using other tools from other companies and was trying to figure out what was going on. And in lots of cases, it's really hard to find good documentation, but Microsoft, I think, did a really good job with documentation. So definitely go and check it out. I can see some people actually agree with me that Microsoft has good documentation. I can actually see your chat and see what you're talking about there. Some people have experience or heard about ML.NET. That's awesome. Okay, so back to the slide. Here I am showing you some of the scenarios that you can use with ML.NET. That is not the whole list, because the whole list is really, really long, but those are the most popular scenarios that you can use ML.NET for, like sentiment analysis, object detection, image classification, fraud detection, sales spike detection. Those are really awesome scenarios. They are focusing on different types of data. As you can see, images, like visual data, and also sentiment analysis can be with text, or sometimes sentiment analysis. For sentiment analysis, you need to perform optical character recognition, convert it to text, and then analyze sentiment of that text. But that's a more complex scenario. So here you can see an overview, which I actually grabbed from official Microsoft documentation, how that the model creation works and what you need to do with ML.NET to actually create your model and then use it. So initially, we're starting from the top. Initially, you are collecting and loading data into iData view. Then you are using method called append to create a pipeline. And then after you appended and created the pipeline, you are getting iEstimator, that interface that you can use to actually train the model using method fit. And then after you trained your model, you are getting iTransformer, which you can evaluate. I'm saying you can, but actually you need to evaluate. Usually what real data scientists do, they have that huge data set and they divide it into two parts, or maybe more parts, but at least two parts. One they use for training, and then the second part they use for evaluation. It's usually not a good idea to use the same data set for evaluation, because you already trained on that data, and obviously your machine learning model will recognize that data better than something new. So I definitely recommend using new data set, or at least a couple of new examples to evaluate your model. And then if when you evaluated it and it went well, you can actually go ahead and save it, and then you'll have the real model that you can use anywhere you want. You don't have to keep it in this application. Once you save it, you can move it around. You can use it offline. You can use it online using REST API, connecting to it through Azure functions, through Logic apps, through web apps, whatever you want to use. I know before they had a big issue, they didn't support ARM, so it was kind of hard to use ML.NET with mobile applications and with IoT solutions. But since probably a month or so ago, they started supporting ARM. So now you can use it with IoT solutions, mobile solutions. I created, so before that latest release, I actually created Xamarin application, which used the ML.NET model. And there I actually had to use that middleman, which was the Azure function between. So technically the Azure function was calling the model, model was processing the data, and then it was returning everything to the function, and then function was passing it back to my Xamarin solution. But now I don't have to do that. I don't need the middleman, and the model can be stored right inside your mobile application. But you also need to be mindful about it, because if your model is too big, or you need a lot of processing power to actually access the model, then you maybe need to store it somewhere else and not on a mobile device. But if you store it on the mobile device, then you can access it offline. You don't need to have internet connection. Okay, so I think I went a little too far from the schema that I have here. So let's go back to the schema. Once you evaluate it, it's working great, then you can save it. If it doesn't work, then you can add more data. You can retrain the model and then start the whole process again. Once you save your model, you can use that model using ML.NET again. You can load the model, again, use iTransformer interface, and then make predictions. You can create prediction engine and then use predict method to get the result. Okay, so we talked about the structure, but now I want to mention my probably favorite part of ML.NET, and that's ML.NET Model Builder. They have two parts there. They have UI part right inside your Visual Studio. I'm currently using Visual Studio 2019. But I think they will keep it in Visual Studio 2022, as far as I know. Don't quote me on that. And also they have a CLI option if you prefer to use CLI. I am more of a visual person. I think for me, better to use the UI, but it's totally up to you. You can use CLI. The model builder actually uses AutoML, and AutoML is not a specific concept for Microsoft. AutoML in general covers the complete pipeline from the raw data set to the deployable machine learning model. So it actually saves you a lot of time. If you are a data scientist and you have a lot of experience creating your model, you understand that you need to figure out the best algorithm to use for your data set. And going through all those algorithms and picking up the best might take a lot of time and a lot of resources, especially if you have bigger data sets. AutoML actually saves you a lot of time. It goes through a bunch of algorithms, try them with your data, and then figures out which one is the best. I know that other companies, they use AutoML tools. They are awesome. If you have experience with models and you have degree in data science, you don't have to use AutoML if you want to. But it can be a good start if you don't have a lot of experience or you just want to save some time. And then the ML.NET Model Builder actually supports a little less amount of scenarios, only because it's using AutoML, and AutoML is not that efficient with all scenarios usually, and also the model builder is newer, and it's like a cover on top of ML.NET. So here you can see the main scenarios are text classification, value prediction, image classification, recommendation, and object detection. I think they will be adding more scenarios, but I can't be 100% sure since I'm not working with Microsoft. I don't know what their plans with the model builder are, but also they have limited scenarios like anomaly detection, forecasting, and clustering. And I think those scenarios are good enough. They're really popular. In a lot of cases, those scenarios are enough for your machine learning build and exploring and actually using it in production. So it is production ready. And now I'm gonna move to the demo. If you have any questions, definitely feel free to ask me or post in the chat, raise your hand. I'll be happy to answer. Okay, I can see a question. Does ML.NET uses TensorFlow or PyTorch under the hood? I am not 100% sure. I don't think it is using, but I know that you can connect to TensorFlow or PyTorch models. I think TensorFlow and Onyx for sure. PyTorch models, I think they were adding them, or yeah, so I'm not 100% sure about PyTorch, but you definitely can work with TensorFlow and Onyx models using ML.NET. Under the hood, I am not sure, so I'm not gonna lie. Yeah, that's the answer. Okay, awesome. So if we don't have any more questions, and before we jump to that crazy demo that I decided to do tonight, I'm actually planning to create a console application from scratch and use ML.NET Model Builder. So it will be console application connected and ML enabled. It's going to be fun, but before we move to the most fun part there, I want to show you how it was before. What was the structure before the latest update? Sometimes you need to work with older versions of Model Builder or older versions of applications, and you need to know the structure of the solution. So before the latest update, and the latest update I think was 1.6 version for ML.NET, when we used the ML.NET Model Builder, we were getting two. So you needed to create your project. And here I have just a simple console application. You need to create your solution and project inside it, that, and then you need to add machine learning capabilities right inside your Visual Studio. And before you were getting two projects in your solution. One was the actual model, and the model is that ML model.zip file. So that's the actual model. And then you could access it using model input and model output there to actually get the prediction out of the model. And you were getting the console application, which was showcasing how you could use that machine learning model that you created. And that was the sample code that you had there before. So you could reuse it. You could see how it all connected to model input, and then the output. You could consume the model and then use the predict methods with the sample data to actually get the prediction result. So that was the structure of your solution before the latest update. With the latest update, I'm actually going to show you how it looks. So now I am going to do the crazy demo that I promised you, create something from scratch right in front of you. Sentiment text. Yeah, it actually comes from the data set. So it wasn't something that I just came up with. Inside the data set, I had two columns. One was the title of one column was sentiment text, and then another was what was it? Sentiment, I think. Yeah. So we'll see the data set, and we'll see what's going on there. So going back to our Visual Studio 2019, you can see I have that create new project pop-up. For now, it's going to be just a console application, but you can create whatever application you want. Go to next, call it whatever you want. You can choose target network framework, and I don't need to show you all that. You probably know it pretty well since you are all probably .NET developers. You are creating a new project. Visual Studio Works today. It's always like that when you need to show a demo live, then something is going on always. So let me show you what's happening here. Yeah, I have empty console application, nothing there. Created from scratch. And now I want to add machine learning capabilities there. How can I do that? Let it load. It's still thinking. I don't know, it's so slow. Okay, so it loaded everything. And now I'm going to right click here and to add machine learning. So that add machine learning actually activates that ML.NET Model Builder. And you should have it by default in your Visual Studio. You might need to enable it, but I think it should be just there. It is definitely there by default. In some cases, you just need to enable it in your settings. So you can see that it is that type of project. You can rename it and then add. When you click on add, you are getting that UI. If you are using CLI, then you don't have to do all that stuff. You don't have to click anything inside the Visual Studio. You just using the CLI. So I don't have a lot of experience with their CLI. I tried it once or twice. It would work pretty well, but again, I'm more of a visual person. Okay, I think we have a question in the chat. Is this a .NET framework or .NET Core application? It actually doesn't matter. You can either create a .NET Core or .NET framework. In this situation, it doesn't matter at all. Okay, so going back to scenario, you can see that there are main scenarios here that I mentioned on my slides. You have text classification, value prediction, image classification, recommendation, and object detection, and some limited scenarios. You can also read about them in the documentation, see the examples, see how they all work, but they're all limited, so you need to keep in mind when you are trying to use them. And here you can see those little tags. It says local ML, Azure ML, and local ML. And for that, you have only Azure ML available. So for some scenarios, especially which have to use a lot of machine power, for example, image classification, images usually they are heavy and they need more power to be processed and more time. So if you don't have a stronger maybe latest version of computer or machine, laptop, then it's totally fine. You can totally use Azure ML, and as we all know, Azure can do anything. I can store a lot of data. It can process a lot of data really quickly. They have machines, really powerful machines available there. So if you think that the machine that you are using locally is not powerful enough for any reason, or you just don't feel comfortable for some reason to use your local machine, then you can connect to Azure ML for some of those scenarios. For others, that is just not an option right now, and you probably don't need more resources for those. I don't want to call them easier scenarios, but with more lightweight data. Yeah, so we're gonna actually use that text classification today. I think that is, for me personally, that's the most straightforward scenario there. It's pretty easy to understand it. So we're gonna do text classification. You can have several categories there, but tonight we're just going to do one category. And here you can see my local machine information. So now you know what kind of machine I have and the memory that I have. That is pretty good for the training that I'm planning to do tonight. I also use bigger data sets. I didn't try to do anything crazy, like upload a lot of images and do heavy image training. But for that scenario, that actually works pretty good. So next step, you have two options for your input. You can use files located on your machine. Those can be CSV, TSV, or TXT files with data. So the model builder actually doesn't have that capability to process your data and maybe to clean it out. As I mentioned before, that you need to make sure that your data is clean. You're supposed to clean it before uploading here, before starting your training. So that might be a downside, but maybe it can be an upside, because usually when you are ready to jump on and start building your machine learning model, then your data should be ready, should be cleaned by that point. So, and the second option here is the SQL Server. I'm gonna use the file tonight. I hope I have the right file. Yes. So I have two data sets. One is bigger, it has 40,000 rows. I don't think we have enough time to actually use that data set. That one is better. We're gonna use 250 data rows available just to save the time. Usually 250 is not enough, but it will take less time to actually train the model on the data. And going back to the comment that Santosh actually mentioned, the sentiment text, that's the sentiment text. So those are just titles of the column, and you can update them before uploading here. That can be part of the cleaning. I didn't do anything. Where I found this data set, I actually found it in GitHub in one of the examples that Microsoft provided for ML.NET. And that is really useful because when you want to just try how it all works, but you don't know where to find the data set that can be used for like demo or training purposes, then they have some data sets available there. They're good enough. Yeah, Kaggle data sets. Yeah, Kaggle is really good. So if you want real data sets, Kaggle is the place to go. I used some of their data sets. I'm not sure if that 40,000 rows is from there. I just don't remember, but I definitely used some of their data sets. And they also have competitions there. They're fun. Okay, so once you uploaded your data, you have an option to select your label, and we are going to predict sentiment. They also have advanced data options, which you can open. You can format your data. You can change the settings for your column. For example, if you have a lot of columns and some of them are unrelated, you can actually ignore them. You can assign features and labels. So usually you have one label that you need to predict, and then feature, those are supporting information. So based on the information you have in every feature, you will have your prediction. So here we have, we are predicting sentiment based on the text that was provided. Okay, so we don't need to do anything here since we have only two columns, and we're gonna go to next step. Next step, you need to train your model. And here they give you average time that you might want to use for training purposes. They have a good link here to an article about setting up the time. So when you're not sure how much time you need, you can read the article. You can read some information online to figure it out, but you always have an option to train it more. So you start training it once, maybe 10 seconds, and that is not enough. You can train more to figure it out. So we'll start with 10 seconds. And you can see what's happening there in the output. It is checking the algorithms, a bunch of them. Since it's only 10 seconds, it doesn't have time to check a lot of algorithms, only 2 of them. But you can see all the output, the accuracy, the duration, number of iterations, and then you see that the best accuracy was 70%, and the best model or the best algorithms was that one. And you can also read about all the algorithms available in the documentation. So the training time was 7 seconds and 7.61 seconds. And 2 miles explored. So you have all the information, and the code was generated as a result of the training. You can train again. I would actually go ahead and train again, because usually 10 seconds is not enough. If you have bigger data set, you might want to use way more time than that. So let's train for 20 seconds and see how many models, how many algorithms we can check. So now it checked 4 different algorithms, and you can see all the information here, duration for each of them. And then actually the accuracy went down, and it shows a different model. So you might want to play with the time. Sometimes you are getting a better algorithm, but the accuracy is getting lower. Here, I can see 2 reasons why it's happening. First of all, the data set is pretty small. 250 usually not enough. And then the second problem is that time to train, you need to find the optimal time. So here I'm just guessing, but when you understand it better, maybe with usually it comes with experience, you can train it longer. I would recommend to train it a little longer than 20 seconds, but now we don't have a lot of time for that, so that's totally fine. And since we are not going to use it in production or for real application, I think 62 is going to be okay for tonight. So we're going to move to the second to last part, is that evaluation. So you can evaluate your model. It kind of repeats you the accuracy, so you don't expect too much. And the model, the algorithm is used for the model creation. Here you can type your own text, or by default, it actually adds text from that first row from your data set. But as I mentioned before, if you are building something more real that I'm doing right now, you need to separate data in your data set into at least 2 parts, one used for training, the second one used for testing. I didn't do it here because my data set is pretty small. So, and also it is just a demo, so you can understand how it works. So let's use that text that was here by default. We can click on predict. And actually it is not sure. It is 50-50. And we can go back and train it again, because that result is not good, especially on the data that it was trained on. So if you see something like that, I definitely recommend you to go back and retrain it. With that accuracy, the result should be better, but it is not critical for the demo purposes. I just want to show you how it all works and give you some tips how you can improve it. So next step is consume. You can actually go ahead and copy that code snippet so you don't have any junk in your solution. Any unused projects. If you remember that I showed you before, you were getting 2 additional projects inside your solution, and a lot of people probably didn't want to have those additional projects inside their solutions. So it was a challenge for some people, and that's why now you can just copy the sample right from here and paste it right in your project. But you can also create that sample project for console application or web API. Let's actually copy the console application, and you can rename it, add to solution, and then you got that console application with the example for using your ML.NET model that you just created. And the next step actually offers you to deploy your model and improve your model. We are not going to do it tonight. ML Ops is really big right now. So if you are interested in specifics of model deployment and the pipelines, definitely check out documentation online. There are lots of resources. There are lots of videos available on how to do that. So I'm not going to cover it tonight. And let's go and see what's happening there. I can see questions in the chat. What level of accuracy would you say makes a model valid? Greater than 80? That's a good question. Usually greater than 80 should be good, but it depends on what kind of solution you are building. If it's mission critical solution, if you are using it with IoT, and you need to be more precise, then definitely the level of accuracy should be more. It will probably never, I know, never say never, but it will never be 100%. But you know, the more mission critical application it is that you are building, the more accurate it should be. But usually for something not that critical, you can keep it above 80% or around 90%. And then, you know, when you keep your logs and failures and see what's happening with the model, how it reacts, what is working, what is not working, then you can actually go back and retrain the model using new data, so it will be more accurate eventually. So yeah, that was a lengthy answer. Okay, so let's go back here and see what is happening. So what was created, as you can see, we didn't get any additional projects here. That one, the console, I added just so I don't have to write anything, and I can just show you out of the box example. But you don't have to add anything here. You'll have only your application with that ML model. Yeah, so with that ML model config that you have here, and under that you can see everything that you need. You have the training part, the consumption part, ML model.zip. That's your model, which you can move around. You can actually remove everything and then use only the model. I don't recommend it for beginners because it's interesting to understand how you can access the model and see good examples. And you know, you already have the input, the output. You just need to access it. It makes your life so much easier. So the training part here, let me move it down. You can see how it trained. So all that code is ML.NET code that was used to actually train the model. and create the model. You can see some of the information that I mentioned in my slides, that you are transforming it, appending some stuff and transforming it again, but it has been done for you. You don't need to do anything, but if you want to if you don't want to use the model builder and want to write your code from scratch, that can be a good example on how you can start writing code without the model builder. So that's an example of the pipeline. And then if we go here to the consumption, you can see that that's input. So you will be providing the sentiment text. And then as an output, you will get prediction, and that will be sentiment, and then the score. So the score is level of confidence, how confident that the model about that prediction. And now let's go to the example here. And it's the same example that was provided in that little window before I closed it. And also the same example that was used in previous versions. So we are providing the text. You can actually replace the text with the input that your user provides, and then analyze it, and then get the prediction result. So I am gonna improve it a little bit since we have a couple of minutes left. I want to actually make it more custom, so it is not all hard-coded. I'm gonna do console, write line, and I'm gonna ask for users' input. And then I'm gonna get that input. And yeah, since it's a console application, I'm gonna use the write line and read line. Pretty straightforward. I'm gonna get that input from user, and then I will replace that hard-coded text with the input. And that's pretty much it. And then you actually gonna have the sentiment text repeated here, and then the prediction. But the prediction will be 0 or 1, and that is not enough information. So since you saw the data set that I used, that might be obvious for you that 0, that is non-toxic, and 1 is a toxic sentiment. But when your user sees 0 or 1, that doesn't mean anything for them. So we're gonna improve it a little bit and use more detailed output. So if it's 1, then it returns toxic. And if it is not 1, then we're gonna return none. And what am I missing? Okay, the brackets. Okay, cool. So now it is pretty much a ready solution. We are getting input from your user and then analyzing it and then returning text, the predicted sentiment as text. So let me actually run it and show you how that works. Okay. Oh, yes. Okay, because I updated I updated in that sample console application, and I have banned a different one. So let's run the one that I updated. And you can see a lot of information, what's happening there, the sentiment text repeated, and then actually predicted sentiment is toxic. So apparently this meetup is amazing. It's toxic, but you probably guessed that that is kind of expected because the training didn't go that well. We didn't have enough data. We also didn't train it for quite some time that it needed. And, during the evaluation, it was 50-50. So not a good model to use, but you can see that that actually works. And what you need to do, you need to actually update your data, add more training time, check it out, do another evaluation, make sure that the accuracy is higher, then you're going to get more meaningful and relevant results. So that's pretty much it that I wanted to cover. Let me know if you have any questions, post them in the chat. Feel free to unmute yourself. Yeah. I don't see any questions in the chat. But yeah, if you have any questions later, let me reopen the first slide.
I have a question.
Oh yeah, okay, yeah.
So thank you for this session. I think this was what I needed because previously I've sat through sessions and it has pretty much gone over my head. But the way you explained it came off really well for me. So the question is, how many, generally, let's say, you're running the training model. How many times do you have to run it in general to get it to a good point? Is that like a case by case basis?
Yeah, it's usually case by case. With experience, you kind of understand how much time you need for training and also how much data you need for training. But when you're just starting out, you train it and then you go evaluate it. And then if you're not satisfied with results, then you go back and add data, change the data. Maybe the data wasn't clean enough or something was wrong, so you go again, check your data, add time, and then see if it's getting more accurate. Usually it doesn't take that long, or yeah.
Okay, thank you.
Yeah, I was kind of curious. So these models that you use, where can you like browse some of those? I mean, you showed that table of some kind of popular uses. Are there like just canned models for different types of things kind of just available out there that people are publishing? How does that part work?
Yeah, so there are lots of really data sets that you can use. I would recommend to still go ahead and make sure that they're clean and accurate, because people post all kinds of data sets online. You can't be 100% sure. Microsoft has a couple of sample data sets that are smaller and they good for like demo, or if you want to just check it out, like the one that I showed tonight. Or if you want real data sets, then Kaggle is really good. I saw it in the chat that someone actually posted a link. They have good data sets there. Some of them are free, some of them are not. They also have competitions there. And then usually if you're working for a company and then you build in something real, then usually you have some kind of data that accumulated from your customers or from other solutions. Yeah.
It's super interesting. I mean, I know almost nothing about it, but like for like image, I guess image quantification, how would somebody who doesn't really know anything about that, how do you like select the criteria that you could use to apply against those data sets, or if you had data sets? And that's a super vague question, but like how do you define these criteria? Does that even make sense?
So you're not actually defining any criteria for images. If you are using AutoML, whether it's model builder or something else, then it will figure out the best algorithm for your data, whether those are images or text data. If you are not using AutoML and you have to go and do everything manually, then you need to have a good amount of images from different angles. Like if it's an object detection solution, then you need to have pictures from different angles and with different lighting. But yeah, you can, as I said before, you can upload them, train your model, check the accuracy. If it's not accurate enough, then probably the data is the issue. So you need to add maybe more angles, maybe if those are different objects, then more of different types of objects.
Is there kind of a ballpark for like what kind of size of data set you need for some of like, I guess it's probably too vague to even say, but I mean, you're probably looking at like hundreds of thousands of images or something like that for a lot of these data sets, I would think.
It depends, as
Right,
always. Yeah. But for example, if you are using cognitive services, they have that custom vision service, and there you don't have to have a lot of images because they underneath you already have a model that was already built on all those images that Microsoft has, and then you're kind of retraining it with your specific images, so you don't need to have a lot of them. If you are using more custom tools like ML.NET, then you need to have more images, but not maybe 100,000. It actually, yeah, again, it depends. If it's like something small and precise and you need really high quality and high accuracy, then yeah, the more images you have, the better.
Gotcha. Okay, thank you.
So we have a few more questions in chat. Isaac asks, can it run in a phone in MOI?
Yeah, so I talked about the example with Xamarin. So before the latest update, I had to use Azure functions in between because ML.NET didn't support ARM. Now it supports ARM, so you can store your model right on your device and then access it directly from your mobile solution. I have Xamarin as an example because I've used it. With MAUI, I haven't tried it, but I assume you can use it with MAUI. I actually have that project in mind that I will try to explore sometime soon to try to use MAUI with ML.NET.
Later this month, we'll be having another meetup talking about .NET MAUI, so come back and ask that question there.
Good point, Tim. Thanks. We have another question. Andre asks, are there any good websites to learn about that have a catalog for deep learning architectures?
Oh, good sites. I read a bunch of books about deep learning, and then Microsoft, they have some examples in their documentation. I know that Google and Microsoft, they have good information about deep learning techniques, some specific data sets that you might need or data points, but lots of people do research around deep learning models. So you just need to find it online somewhere. I don't have any specific resource in mind other than, official documentation.
And then we have another question. Can we get to choose between Microsoft algorithms and sklearn? I hope I'm pronouncing that correct. Do we get to choose between those for like a cluster scenario, or do we have to stick to Microsoft's proprietary algorithm while using Model Builder?
So I don't remember all the algorithms that ML.NET and AutoML actually provide, because there are lots and lots of algorithms. I know they have all those algorithms in the documentation, but there are just a lot of them, so I don't remember all of them.
Okay, I don't see any more questions. Anyone else have any questions? So, Veronika, yeah, are we going to get these slides and code samples?
So the code samples, I didn't do much. I just created it from scratch. I can share the solution that I created if that can be useful for people, and slides as well if needed.
Sure. If you can email those to me, or put it on a GitHub and shoot me a link, I can share it with our audience.
Okay.
All right. Tim, you want to take it through?
Sure. Well, thank you again.